All right, Weihan, thank you very much for inviting me here to Karl in Aachen at the Campus Boulevard, which is, I think, a well-known research campus of the RWTH Aachen. And today we want to talk about AI for battery research. What
Exactly.
does that mean? Before we jump into today's discussion, I would first like to ask you the question, how did you enter the field of batteries?
Yeah. Thanks, Simon, for visiting us today. I think it's really great to have you here. That's a very good question, right? So I think that's the year of 2016 when I was doing research at MIT, where I started to look at AI and to look at the physical models for batteries.
Mm-hmm.
And together with the colleagues at MIT, we started to work on integrating both of them for the future battery management system. That's where I started to, came to the area of AI and digitalization. And after my visit there, I came back to
Already back then?
exactly,
Wow. Okay.
exactly. I think if you count, it's already more than 10 years right now.
Mm-hmm.
And after my research there, I came back to Germany and came back to Aachen University and started my PhD phase with Digitalization together on this topic,
Mm-hmm.
AI for battery management system. That's where I came from.
Yeah. And maybe to just give us an overview about, you just mentioned Dirk Uwe Sauer and the ISEA Institute, which is a well-known battery research institute in Germany. Can you just briefly explain what ISEA and Karl in this regard are about, so that we kind of have an overview?
Yeah, exactly. ISEA, or we can call it in English ISEA. So this is an institute in Faculty for Electrical Engineering and Information Technology
Mm-hmm.
at Aachen University. And the institute has already 60 years of history, and we celebrated last year, and we are 60 years old.
Mm-hmm.
Whether you can believe it, yeah. So because battery, if you look at battery research, right? So it's not that long, but actually at the very early phase of our institute, we already started to work on battery technology at the very beginning, lead acid and so on.
Okay.
And then afterwards, I think my colleague Dikuwa Zawa joined Aachen University and our institute like 20 years ago,
Mm-hmm.
where he was the very first professor in Germany and Europe for battery system technology.
Mm-hmm.
And now we have like in total 4 professors in our institute. My colleague Di Dunke is leading the activities in power electronics and electrical drives. And Zawa is leading the activity for battery system technology from cell to system, everything included. And my colleague Egbert Fickmeyer is leading the activity for chemistry lab, material development, and also
Mm-hmm.
production technology. And myself, my group is relatively fresh, and I started my junior professorship actually at the beginning of last year. And currently, I'm leading a group of about 20 PhD students, researchers, research associates in the direction of AI and digitalization for batteries, which is a new
Yeah.
topic, but it's a very important topic right now in Germany and Europe.
Mm-hmm.
And the center, Karl,
Yeah.
yeah. So maybe people are okay. What is the relationship between ISEA and Karl? So Karl is a new battery center which we built up together with many other colleagues in Aachen, Münster, and also Jülich as a very strong collaboration with many chairs and professors from 3 institutes, which is located in Aachen. And we are working with many colleagues here, right, to build up this specific center to understand aging, reliability, and lifetime prediction for both batteries and power
Mm.
electronics.
So that is what Karl stands for, right?
Exactly. And Karl is a famous name, right? So in Aachen.
Yeah, that's true. So let's jump into the depth of AI for batteries. Can you just explain it in layman terms? What does it include? What are the pillars? How you kind of categorize, structure this research to get it more comprehensive?
Yeah. Yeah, that's a very nice question because people will think, okay, what is the role of AI for battery technology? Because this sounds like 2 different areas. But actually,
Mhm.
AI has been widely used already in battery research and industry for many years.
Mhm.
So in the past 10 years, we at ISEA or Carl has already used AI in different sections of battery research,
Mhm.
from image analysis, for example, for CTs, for SEM images, to automate the way we do image analysis to understand aging and reliability. Further to modeling, we are using AI machine learning tools to build up better models, which the traditional physical model cannot carry out a lot of information there.
Yeah.
And further, we use it for testing, to accelerate testing, to integrate the digital models into the testing world, to evaluate the data on in real time, to accelerate and reduce the cost of testing. And further, we use it in optimization of our systems. We are working closely with automotive, stationary, energy storage system partners from the industry to help them build up their digital twins for battery systems to analyze the data. So you see, that's the history of AI for batteries.
Yeah, it's quite an extensive work. So I think we need to explain it with one or two examples to make it more tangible what your work really involves. And what I'm on this expedition are always interested in, where's the connection to the industrial uptake? Who can leverage this research knowledge, this innovation to industrial adoption, and thereby also creating wealth for a continent? So what have you brought with you that you can explain a little bit more the depth and
Exactly. So we are not working on like very, laboratory based application. We are really working very closely with the industry. So here at IZEA and at Carl. So I can give you several examples how AI is being used. Most importantly, we are focusing on digitalization. So to develop the digital models and digital twins for battery cells and systems. One important application is testing.
Okay.
As you saw today in the tour of Carl, we are building up, the new testing methodology with industry partners to integrate AI into testing to make clever decision in design of experiment.
With testing, you mean testing of battery cells?
Exactly. Testing cells, testing modules, and even systems.
Okay.
So for testing, there are different kinds of testing, like characterization test, performance test, right, to check the power, energy, and so on, but also aging test and safety test. Usually, aging test, for cyclic aging, for example, we need 1 to 2 years to understand the aging behavior. But with AI, we are working on the new technology for the near future. We can cut this time from years to months and even weeks.
What allows this shortening? Is it to measure more precisely the voltage signal and understand what fluctuations mean at measuring at different frequencies? Impedance spectroscopy is likely one tool you're using. Can you explain how the measurement technologies are intersecting now with this digital brain that we are building up more and more in our society, or and also in our industry and research?
So at Carl, so we are working closely with other groups. So this is a mission from different perspectives. We need new sensor technology. That's why colleagues are working on input, increase the input information by adding new sensing technology. For example, ultrasound. For example, like pressure measurement. For example, thermal imaging. For example, CT. All of this will give our AI model strong information. And the role of us as AI experts is to think about how to build up AI models, taking all of these informations in a short testing period to predict the future performance of battery. And then help us make clever decisions to use the testing channels more efficiently. One example, for example, we use different cells in testing, different testing points. We can decide in the future with AI, when should we stop the test? Which cells can be replaced with another cell? And this decision will be made by the agent from AI.
Because if you model it physically, you always know why things happen. So causality is possible because you build the model and thereby you know when I tweak this value, this happens, right? That's general the analytical model that you can build up. With AI and machine learning, you're kind of building a black box. And my question now is, because cynical voices would say like, yeah, that's nice that you get something out of it, but do you really know what's happening? And how can you ensure that there is a repeatability in your measurements and predictions?
Exactly. That's a really hot topic also in our AI field.
Mm-hmm.
So we try to combine physics and AI together. We know the challenge, yeah, especially for automotive application. They have a very high safety requirement.
Mm-hmm.
We need to have a very, reliable models if we want to, put them into the car. That's why we are working on different strategies to integrate both worlds into one thing.
Mm-hmm.
How can we do that? We mainly have two strategies. The first strategy is to keep the physical model the backbone. And then we use AI to solve the problems of such models.
Mm-hmm.
For example, to accelerate the simulation of such complex PDEs. To
PDE means what?
Yeah, PDE means like partial differential equations
Okay.
because they have different, mathematical equations involved, and calculation and simulation always takes a very long time.
Mm-hmm.
And we can
Just for the audience
exactly, yeah.
follow you along. Yeah.
And we can use also AI to parameterize
Mm-hmm.
such models, even without opening the battery cells, which saves us a lot of time and cost in chemistry lab.
Yeah. So on our tour, I was gifted to see the inside of your labs, and besides the chemistry lab, you also showed me the testing facilities, meaning all the 600 plus channels that you have here, kind of outside of the building, of course, in order to have a safe testing environment. But also inside the building, you had some automation and robotization equipment. Maybe you can also explain in terms of the chemistry and material development what the role of AI can be there. Because I was also intrigued to see, okay, things are moving, but please explain yourself.
Yeah, exactly. So as I mentioned, we have two strategies.
Mm-hmm.
The first one is to integrate them from different directions. And the second, what I want to highlight together with the topic you mentioned, is the internal integration. So we are developing new model structure, yeah, to have, for example, physics-informed neural networks or other surrogate models, so that we build up totally new structure, which has, the neural network inside, but also the integrated physical constraints.
For which application now to
Yeah.
make this comprehensible?
For different applications, from production to testing and finally the field application.
Mm-hmm.
Because with this kind of physical constraints inside the machine learning model, the OEMs can trust such model. This will not be a black box model anymore, rather gray box model.
So
Yeah.
the use case here is you have an automated testing setup that tests the different cells with respective different parameters like cell chemistry, etc., or even different ages, and then you put them on a test bench in a repetitive manner to collect data points, correct?
Yeah.
And then this is already an optimized procedure, as I learned. But then you're taking this data, of course, and analyze it and build the neural networks and everything that allows you to make a curve fit, so to speak, to predict reliably. Is that correct?
So that's what we just had to look together in a tour, right? So we
Mm.
have two very important test benches, which we are using them to develop the AI models for testing. So what we are doing there is to use robotics,
Mm-hmm.
to automate the way we characterize the battery cells. Yeah, so I think the industry is also doing similar tasks, which we are also collaborating with. But the goal of us in this test bench is to accelerate the way we generate data.
Mm-hmm.
Because we are focusing on AI,
Yeah.
and AI need high quality data set. We can use that test bench to collect data from electrical, thermal, and mechanical information, right? From electrical testing, impedance measurement, thermal imaging, and finally CT.
Yeah.
And all of this data are the physical information. And then we build up the model with AI and the physical model together, integrated into one box
Yeah.
to estimate, for example, the physical parameters in a very, very short time. And this information is exactly what the OEM and the manufacturer need in a short time so that they can further take it
Mm-hmm.
and optimize their production lines.
Can you give us a perspective on the extent of your data set and the analysis? Because I think from the outside, people say like, yeah, many research institutes are doing this, and there are many laboratories like Carl. But please give us an an understanding of the size and the magnitude of the research you have done over the last decade, but are also currently doing.
Yes. So as I mentioned, my colleague Professor Sauer has already, built up the whole institute since the beginning of 2000s. We have more than 20 years of experience of battery testing. So what does that mean? That means we have collected data for all different chemistries, for all different cell formats from the last 20 years. And with the new car center, we have more than 6,000 battery testing channels for all different kinds of battery testing. Yeah, together with the environmental load laboratory, where we can, just put the whole car there or the whole energy storage system there to test the performance. So this is the source of the data for our daily life.
Yeah. Then let's talk about how we bring this potential all the way to industrial adoption, because an institute with that heritage and that well equipped has something to say in battery research, also globally, as I understand, also looking at the papers that you issue. And now coming to the collaboration with other research partners, but also industrial adoption. Can you explain how this interplay works, and to give us an understanding on this back and forth between industrial players, because there's always this thing that people from industry and also on the expedition tell me, we would love to work more with research, but they're so slow.
Yeah.
So please bust that comment.
Yeah, I think that's a fair comment from the industry, but actually this is also my call for action. Yeah, so for the academics and also industry in Germany and in Europe. So we are having a lot of very new technology, very good technology, and we need to work together. And the collaboration modes here in Aachen University or in our institute is very successful until now. So we are collaborating not only with research institutes from the whole world, from the US, from other European countries, from Asia, South Korea, Japan, China, and so on different topics. Yeah, we are trying to provide what we are doing here, for example, testing data as open access data sets to the whole community, trying to make them open access so that all the other researchers, engineers can use it, including all of the models that we have developed. We make them open access so that everyone can have access to it. And with industry, I think we are very successful in the collaboration, especially in automotive, and also the engineering and the system level collaboration. For example, one of my group is working on field data analysis and digital twin development. And there all of the data are coming from the industry. So Aachen University have a very traditional way to collaborate with industry based on contract and NDA to protect all the confidential information, but we are delivering directly the service and research to our industry partner to transfer everything we have learned until now to their system, to their data set.
Okay, I think that role is understood. And there with the shout out to all industry players to talk to you, Weihan, on leveraging AI also for their business. I would like to take a step back and ask you some key questions that I ask every participant of this format. And that are the key challenges, the potential, and your call to action / to collaborate to bring Europe as a battery nation, or as a battery continent, we should say, forward. So briefly, what are the challenges that are holding us back?
Yeah, I think one of the important challenge, and also I call it also as opportunity, because I think they come together. Yeah, the challenge is that we need to accelerate our development, our research.
In which field?
Everything. In research, in transfer from research to industry, and also in industry. Yeah. So we need to be faster than before, because this is a very dynamic world. You see that the new chemistry coming out, right? So they are
month by month,
yeah, they're updating it. And for acceleration, AI is a very, very important tool. And we are not, bad in this field. I must say, I'm honest. Everyone
we're
in
not
the world,
streamlined yet, I would say.
Yeah, exactly. They are looking at what we are doing here at Carl in Germany, in AI and digitalization for automotive, for stationary energy storage system. And now we are also supporting the production partners in Germany.
Okay.
But we need to have an eye on it and know how important it is, because with digitalization and AI, we have the data, we have the models, and we have the results that we can trust to accelerate the whole development of the battery technology from production further to cell development and finally system.
Yeah, you just mentioned the first point. I mean, that is the part, the sector in the battery industry where I'm coming from, battery production. So we are really good, I think, on analyzing field testing, etc. So this
Exactly.
is with the Cure and all those startups in Germany, like spinning also off from here, right?
Yes.
There's a lot of intelligence, literally, available. And you just mentioned I'm also supporting on the production end. This is not a deep dive on today's podcast, but I'm also curious on seeing that. And that kind of segues over to my second question on the potential. Do you really see European potential to build a battery production industry also?
I truly believe it. I think I'm from Asia. I
Mm,
have worked in industry in Germany, also academia, for more than 10 years here.
yeah.
So I know we have strong experience in automotive, in all the other engineering field.
Mm-hmm.
Why can we not make our own battery cells and systems?
Yeah.
We can make it. I mean, we were a little bit slow in the past 10 years or 20 years in this, build up of this technology, especially in production. But we can collaborate with our partners, our colleagues from other countries in Europe, and to make this goal to coming true together. But to be honest, I think we still have a lot of challenges, as you see, and we need to have a very good strategy, for developing this in Europe,
Yeah.
but with strong collaboration.
If you say collaboration, what would be your call to action and to collaborate as the final question?
Yeah.
So how can we get ahead?
And we, as a research institute,
Mm.
which is very application near, that's why our daily life is to support our industry partner to make progress, to solve the problem. Especially for my group, our role or the vision for the future is to build up this digital world for batteries from production, material development, further to cell level, so cell modeling, cell testing, and finally to system level, to understand the data set from the field, to use it to optimize our system. But you see, this is a huge world, and we cannot make it alone. So we would like to collaborate with all the industry partners, all the research institutes, quite interdisciplinary, because we need expertise from mechanical engineering, material science, AI, data science, and also mathematics. That's why I'm calling for collaboration from industry and also from all the other area.
All right. I think you're speaking from my heart. That's the reason why I started and funded this battery expedition campaign. And I hope to, do my fair share on bringing you guys closer together and all of us closer together. So, Weihan, thank you very much for this open, honest conversation, giving me the insights. And
Thank you for having me, Simon. I think you are doing a wonderful job. I think we need you to connect a lot of industry partner and academic partner together. And this year, 2026, as we shortly discussed before, is a very important year for us, for Germany, for Europe. And we need to push it and work together and with all the partners, in the direction of digitalization and AI.
We'll do so, Weihan. Thank you very much.
Thank you.